Mr. Clown here from Clown Maths. Today we're going to look at the whole of polynomials in the Higher Maths 2023 exams. That includes factors and remainders, identify polynomials from their roots, intersection of a line of polynomial, completing the square of a discriminant, and quadratic inequalities. Okay, looking at factors and remainders, SQA Higher Maths 2015, paper 1, question 3. Show that x plus 3 is a factor of this polynomial and hence factorise fully. A couple of ways you can do this, but the most common way is synthetic division. So looking at synthetic division, you take your coefficients of these. So I've got 1x cubed minus 3x squared minus 10x and plus 24 on the end. And I'm subbing in x plus 3, so I'm subbing in minus 3 because minus 3 is the root. So we drop 1 down. 1 times minus 3 is minus 3. Minus 3 plus minus 3 is minus 6. Minus 6 times minus 3 is 18. 18 take away 10 is 8. 8 times minus 3 is minus 24, and 24 take away 24 is 0. So I can just write a little statement, since the remainder equals 0, x plus 3 is a factor. Now we're done there. Now we need to factorise fully, so we've all done most of the work. We know that x plus 3 is a factor, so we've got x plus 3, and then we've got x squared minus 6x add 8. X squared minus 6x plus 8. So that's x plus 3, and then from National 5, this is just a double bracket. Two numbers at times together to make 8, but add to make 6 is 4 and 2. I want minus 6 in the middle, so it's minus 4, minus 2, and that's it factorised fully for final answer. Integrating the find area, SQA Higher Maths 2016, paper 2, question 3. Show that x plus 1 is a factor, and then solve the equation. So that's not integration at all, but we'll do it for the sake of completeness. Then part B says, the diagram below shows the graph of this equation. Write down the coordinates of point A and B, and then calculate the shaded area in the diagram. So we're going to have to do part A to get the coordinates anyway. So part A, show that something's a factor. We can use synthetic division. So for part 1, I'll set up my synthetic division nice and quickly. I've got 2 minus 9, 3 and 14. And we're trying to show that x plus 1 is a factor, so I can sub in minus 1. So I've got 2 minus 2 minus 2 minus 9 is minus 11, times by minus 1 is 11, 11 and 3 is 14, times by minus 1 is minus 14, we get 0, and we'd need to write a little statement, the remainder equals 0, therefore x plus 1 is a factor of f of x. Part 2 of this says to solve the equation then, well, we've now got x plus 1 is a factor, and we've got what's left over, 2x squared minus 11x plus 14, so that equals 0. We should be able to factorise this, hopefully. We've got double brackets, it must be 2x and x. 7 and 2 make 14, so minus 2 times 2 is 4, and then 7 equals 11, so minus 4 minus 7 is minus 11. So we've got x equals minus 1, or x equals 7 over 2, or x equals 2. Part B, the graph cuts the x-axis at A, B, and C, right down the coordinates of A and B. Well, we've just worked it out. Our smallest x is A, our next smallest is B. So in other words, A equals minus 1, 0, and B equals 2, 0, and C would be 7 over 2, 0 as well. Part 2 of B, calculate the shaded area. Well, that's integral between these two numbers of our original equation. There's our equation, so it's the shaded area is the integral between minus 1 and 2 of 2x cubed minus 9x squared plus 3x plus 14. So we integrate and solve. So that equals, add 1 to the power, x to the 4 over 4, minus 9x cubed over 3, plus 3x squared over 2, plus 14x, and that is between minus 1 and 2. We then get a mark for subbing in, so let's just sub in our numbers. So tidying this up, that's a half of 2 to the power of 4. 9 divided by 3 is 3, so that's minus 3 times 2 cubed, plus 3 over 2 times 2 squared, plus 14 times 2, so that's our first one, big brackets around it, minus our second one, so that's a half, minus 1 to the 4, minus 3, minus 1 cubed, plus 3 over 2 minus 1 squared, plus 14 times minus 1. And quite often after this point it gets a little bit messy, but you're getting another mark just for solving that. But if you can get this far, you're doing really well. So let's just try and get this really tidied up. Dealing with each one separately. 2 twos is 4 times 2 is 8 times 2 is 16. 16 divided by 2 is 8. So we get 8 for our first term. 2 twos is 4 times 2 is 8. 8 threes is 24. So our second term is minus 24. 2 twos is 4. 4 divided by 2 is 2 times 3 is 6. So we get 6. And then 14 times 2 is 28. So there's our first bracket. Minus. Minus 1 to the 4 is 1 times a half is a half. Minus 1 cubed is minus 1, times minus 3 is plus 3. Minus 1 squared is 1, times 3 halves. And we've got minus 14 on the end. Now, you can use a calculator for most of the work on this. I would leave fractions as fractions, but none of this is going to end up being fractions anyway. That equals, using a calculator, tidying up our first bracket, we get 18. And our second bracket, we get minus 9. So it's minus 9. That equals a final answer of 27. So it's 27 as our shaded area, and we're done there. Okay, factors and remainders, SQA Higher Maths 2017, paper 2, question 2. Show that x minus 1 is a factor of f of x, and then hence otherwise solve f of x equal to 0. So for part A, we could use synthetic division. So we get 2x cubed minus 5x squared plus 1x plus 2, and we're showing x minus 1 is a factor, which means that 1 is a root, so I'm subbing 1 in. Drop the 2 down, 2 times 1 is 2, 2 minus 5 is minus 3, minus 3 times 1 is minus 3, minus 3 add 1 is minus 2, minus 2 times 1 is still minus 2, and minus 2 add 2 is 0. So since the remainder is 0, x minus 1 is a factor of f of x. And now we have to solve it equal to 0, so we can just straight away say x minus 1, that's our factor, 2x squared minus 3x minus 2 equals 0. And we need to solve that. So hopefully we can factorise the second bracket. So that would be double brackets. And this is National 5 work, so revised factorising if you need to from National 5, but you've got 2x and x. And I'm looking for two numbers at times to get to make 2, so that must be 2 and 1. So 2 times 2 is 4, minus 1 is 3, so it goes this way. And it's going to be 2x plus 1 and x minus 2. Just a double check. Minus 4 plus 1 is minus 3. 1 times minus 2 is minus 2. So that gives the first bracket is x equal to 1, or 2x plus 1 equals 0, or x equals 2. Solving our middle one, we get x equal to 1, or x equals minus a half, or x equals 2, and we're done there. Factors and remainders, SQA Higher Maths 2018, paper 2, question 7. Part A, show that x minus 2 is a factor, then factorise fully. Then part B is a sequence question. Sequence is not in the course this year, but I'll show part B anyway for the sake of completeness. Show that x minus 2 is a factor of 2x cubed minus 3x squared minus 3x plus 2. So we can set up our synthetic division. We've got 2 minus 3. We've got minus 3 and 2. And it was x minus 2 is a factor, so we can sub 2 in. So dropping a 2 down, 2 2s is 4. 4 minus 3 is 1. 2 1s is 2. 2 minus 3 is minus 1. 2 times minus 1 is minus 2. And we get 0. And therefore, since the remainder is 0, x minus 2 is a factor. And now we can try and factorise it. So we've got x minus 2. This is for part 2. And we've got 2x squared plus x minus 1 from the work we just did up here. That's x minus 2, double brackets, 2x and x. It can only be 1 and 1. So I just need to get my signs right. So it's plus 2 minus 1. So plus 1 and minus 1 here. And that's it factorised for second mark. Okay, part B of this question is a sequence question, so you can skip ahead if you're just wanting to revise polynomials at the moment. But for the sake of completeness, I'll finish the whole question. So it says the fifth term of a sequence is given by u5 equals 2a minus 3, and it satisfies this recurrence relationship. Show that u7 is that. So we just need to go up to u6, then u7. So for part B, u6 from this bit here is a times u5 minus 1, the one before. au5 minus 1. So that equals a times 2a minus 3. Take away 1. So u6 is equal to 2a squared minus 3a minus 1. And now we need to do u7. Well, u7 is going to be a times u6 minus 1. So that is a times 2a squared minus 3a minus 1. Take away 1. Multiplying the brackets out, we get 2a cubed minus 3a squared minus a minus 1. And there's our u7. Okay, going on to part C of this question. For this sequence, it is known that u7 equals u5 and a limit exists. Determine the value of a. So let's do part A first. Part 1 first. u5 equals u7. So I can just write u5 again, which was 2a minus 3. So we know that 2a minus 3 on the right equals 2a cubed minus 3a squared minus a minus 1. And we need to solve this equation. So moving everything to the right, we get 2a cubed minus 3a squared minus a minus 2a is minus 3a minus 1 plus 3. 3 minus 1 is 2. So plus 2 equals 0. So we've now got a cubic to solve, so it's actually back to polynomials. 2a cubed minus 3a squared minus 3a plus 2. We've already factorised that. So taking our answer from part A minus 2, 2a minus 1, and a plus 1 equals 0. So that means that a equals 2. 2a equals 1, so a equals a half, and a equals minus 1. And we've solved that. The limit exists, calculate the limit. So this is just a pure sequence question for a limit to, if the limit exists, that implies that minus 1 is less than a is less than 1, and therefore a must equal a half because the other two ones are invalid. The limit is given by b over 1 minus a. So remember, un plus 1 was equal to aun minus 1. We now know that, so b is our last number, so it's minus 1 over 1 minus a half. That's minus 1 over a half, which is minus 2. So the limit of the sequence is minus 2. SQA Higher Maths 2019, paper 2, question 10. For factors and remainders, show that x plus 3 is a factor. So part A, synthetic division. We've got 3x4, 10x cubed, 1x squared minus 8x minus 6 plus 3, so we're subbing in minus 3. So take the 3 down, we get minus 3 times 3 is 9, minus 9, 10 minus 9 is 1. 1 times minus 3 is minus 3, minus 3 add 1 is minus 2. Minus 2 times minus 3 is 6, 6 minus 8 is minus 2. Minus 2 times minus 3 is 6, 6 minus 6 is 0, and therefore since the remainder equals 0, x plus 3 is a factor. Part B, hence always factorise it fully. So we've already done a little bit of the work. We've got x plus 3, and then these all drop down a power, so it's 3x cubed to start with, plus x squared minus 2x minus 2. Okay, so we've now got a cubic to factorise, so we need to find a factor of this. You can just do that by trial and error, trying 1, minus 1, and so on. So let's start off by trying 1. So for this one here, we've got 3x cubed plus 1x squared minus 2x minus 2. We try 1, and if 1 doesn't work, we try 2 and 3 until we get the remainder of 0. So 3 goes down, 3 ones are 3, 3 plus 1 is 4, 4 ones are 4, 4 minus 2 is 2, 2 ones are 2, 2 minus 2 is 0. Like again, you might have to do that a few times, and you don't have to use synthetic division each time. You can just substitute a number in direct if you want. But I've done it in 1, so I now know that since the remainder is 0, x minus 1 is a factor. And therefore, we now know we've got x plus 3, x minus 1, and we've got our 3x squared plus 4x plus 2 from the bottom bit. So now we need to check, is 3x squared plus 4x plus 2 factorizable? There's a couple ways you can do it, trial and error, but the easiest way is to use the discriminant. If I look at, I'll do this in red, this bit here, and check b squared minus 4ac. b squared minus 4ac is 4 squared minus 4 times 3 times 2. That's 16 minus 12 times 2 is 24, which is negative 8. That means no real solutions. Final answer is x plus 3, x minus 1, 3x squared plus 4x plus 2, and we're done there. Hi, SQA Higher Maths 2022, paper 1, question 13. Part A, show that x plus 2 is a factor of x cubed minus 2x squared minus 20x take away 24. Part 2, then solve f of x equals 0. And then it shows you a graph of f of x, and it tells you that f of x minus k is k greater than 0, has a station point at 1, 0. You can state the value k. We'll get to that in a bit, but let's start dealing with our showing a factor of a cubic. So x plus 2 is a factor. There's two ways to do this. We could just substitute minus 2 into it, or we can use synthetic division with minus 2, whichever one you prefer. I will do the most common way that most people do it, which is synthetic division. So a reminder of how that works. We put minus 2 on the outside, and then the coefficients of our function. So 1x cubed minus 2x squared minus 20x minus 24. 1 just drops straight down. And then I've got 1 times minus 2, which is minus 2. Adding them together to get minus 4. Minus 4 times 2 is 8. Adding them together to get minus 12. Minus 12 times minus 2 is 24. Adding them together to get 0. And we get a mark at that point for using minus 2 in the synthetic division. So there's a mark. Let's move on to our second mark. So we need to complete the division and interpret the result. So we've completed the division, but we're not actually saying anything. We now need to say that since the remainder equals 0, that therefore x plus 2 is a factor of f of x. And that gives us our second mark there for completing the division and also making our statement. If you had done it the other way by substituting minus 2 indirectly, then you would still get an answer of 0, but you would say that since f of minus 2 equals 0, x plus 2 is a factor. So it's the same way. Okay, let's move on to part 2. Hence or otherwise solve f of x equal to 0. Now, this is where the power of synthetic division comes in. If you've already done synthetic division part A, you already know this. If you haven't done it for part A, then you're going to have to divide through. But let's just assume that we're doing it this way. So for part 2, we have got this whole bit, x squared minus 4x minus 12 is our factor. So we now know that x plus 2 is a factor. So f of x equals x plus 2 times x squared minus 4x minus 12. And obviously, like I said in part 1, if you had just substituted minus 2 in, then you'd either have to do synthetic division at this stage, or alternatively, if you do polynomial division, if you know how to do that, you can do it that way. But assuming we've done this, we've got the quadratic factor, so we get a mark for stating this point here. That's our third mark. Then we need to solve it, so we make it equal to 0. So we've got x plus 2, x squared minus 4x minus 12 equals 0. That's just staying where it is because we've already done that, but we need to factorise our quadratic. So we've got x and x. Two numbers at times to make 12, but add or take away to make 4 must be 6 and 2. And since our final result is negative, and one of them is negative and one is positive, just getting them right way round, we've got minus 6 plus 2 is minus 4, so that equals 0. If we get to that point, we get our two brackets, we get another mark there. Or alternatively, if you forgot how to factorise or couldn't do the factorising, if you had substituted into the quadratic formula correctly, which would be 4 plus or minus the square root of minus 4 squared, take away 4 times 1 times minus 12, all over 2 times 1, you would get a mark instead for that. And then your final mark is just for working that out to get your factors. So we've now got x plus 2 equals 0, or x plus 2 equals 0, or x minus 6 equals 0. So x equals minus 2, or x equals minus 2, or x equals 6. So we get our final solution of minus 2 and 6 for our other remaining factors, because hence otherwise solve f of x equals 0. We've already got 1. So our other one for getting minus 2 and 6. And since it's a repeated factor, we could just say that x equals minus 2 or x equals 6, just to be clear. Minus 2 and 6 give you your final answer mark. The graph of f of x minus k has a stationary point at 1, 0. State the value of k. We know that this must be minus 2 because it's crossing the axis there, and this must be 6. Now, if this has a stationary point at 1, 0, that means that this must have shifted along to the number 1. There's 1 there. It's shifted to the right by 3, and therefore, since it's shifted to the right by 3, k equals 3 because it's x minus k. So it's x minus 3. So k is 3, and we get a mark just for working that out. So there's our final mark for this question. Identifying the coefficients of a cubic, just a quick one on this. SQA Higher Maths, this comes through specimen paper. 2018, paper 1, question 8. For a polynomial x cubed minus 4x squared plus ax plus b, we know that x minus 1 is a factor, and minus 12 is the remainder when it's divided by x minus 2. Determine the values of a and b. So it gives us a couple of bits of information we can just use. So first one, if x minus 1 is a factor, x equals 1 is a root. So we can just sub that in. So we've got x cubed minus 4x squared plus ax plus b. X equal to 1 means when it's 1, we get 1 cubed minus 4 times 1 squared plus a times 1 plus b. All that stuff must equal 0 because x equals 1 as a root. So 1 cubed is 1 minus 4 plus a plus b equals 0. So a plus b we could say equals 1 minus 4 is minus 3. So we get 3. There's one equation. We're obviously going to get another one in a minute and just do simultaneous equations. The other thing is minus 12 is the remainder when divided by x minus 2. X minus 2 gives a remainder of minus 12. So I get 2 cubed minus 4 times 2 squared plus a times 2 plus b, but now the answer to that's minus 12 instead of 0. Or you could use synthetic division, but this is probably easier. So tidying that up, we get 8, 2 2s are 4, times 4 is 16, so minus 16, plus 2a plus b equals minus 12. 8 minus 16 is minus 8, plus 2a plus b equals minus 12. So that means that 2a plus b equals minus 12 add 8 is minus 4. And we've now got two equations that we can solve. We've got 2a plus b equals minus 4. And the other equation we just worked out was a plus b equals 3. So we can immediately take them away from each other because the b's are the same sign. 2a minus a is a, minus 4 minus 3 is minus 7. So we've got an answer of a is minus 7. So that means that a plus b equaling 3, minus 7 plus b equals 3. So b must equal 10 for our second solution. X cubed minus 4x squared plus ax plus b. That's x cubed minus 4x squared. A is minus 7, so minus 7x, and b is 10, and equal to 0. Now remember, in the question here, it already told us a factor, which was x minus 1 is a factor. So using synthetic division on that, we get 1 minus 4 minus 7 and 10. 1 minus 3 minus 3. Minus 3 minus 7 is minus 10, minus 10, and 0. So that means that we know that we've got x minus 1 and x squared minus 3x minus 10 equals 0. X minus 1, double bracket, x and x. 5 and 2 minus 5 plus 2 is minus 3, and therefore x equals 1, x equals minus 2, or x equals 5. And we're done there. 1 minus 2 and 5. SQA Higher Maths 2016, Paper 1, Question 15. Identify a polynomial from its roots. So the diagram below shows the graph of f of x, which is k, x minus a, x minus b squared. Find the values of a, b, and k. There's one of my roots there. And there's the other root there. That's a repeated root. And I know that because it's a turning point and a root. So that one is my b, and the other one is my a. So I can immediately say for part A, f of x equals k times x minus 4, x plus 5 squared. And then we can use the point 19 to work out our k. X equals 1, y equals 9. So we get 9 equals 1. K times 1 minus 4, 1 plus 5 all squared. So 9 equals k times minus 3. 1 plus 5 is 6. 6 is 36. So 9 equals minus 108k. So k is 9 over minus 108 minus 12. So we've got k as minus a 12. We've got a equals 4 and b was equal to minus 5, remember, from our roots, 4 and minus 5. So we're done there. Part B says, for the function g of x equals f of x minus d, where d is positive, determine the range of values for d so that g of x has exactly one real root. Okay, let's have a look at this. If it's got one real root, it only crosses the x-axis at one point. So this is going to move down, so that makes it go, but it's still going up. So this turning point has to go underneath here. So that the only place it crosses is when it first initially drops down. Then it goes up, and it's going to turn before it hits there and go back down. Well, that length is 9, so d must be greater than 9, and it's as simple as that. So it's just really working that out by looking. So for part B, I just write d is greater than 9, and we're done there. Unusual question, SQA Higher Maths 2018, Paper 1, Question 15. A cubic function is defined as a set of real numbers. X plus 4 is a factor, x equals 2 is a root, f dash minus 2 equals 0, and f dash x is greater than 0 when the graph crosses the y-axis. X plus 4 is a factor, means that x equals minus 4 is a root. That's where it crosses the x-axis. X equals 2 is a repeated root, which means that it's also a turning point on the x-axis. That's what happens when you've got a repeated root. So we can start drawing a graph. We can look at the other options in a minute. But if we draw a y and x-axis, just a quick sketch, we've got minus 4 as one of our roots, and we've got 2 is, I'll just put it here actually, as another root. And when looking at our derivatives, f dash of minus 2 equals 0. So we now know that at minus 2 at some point, we've got a turning point as well, not on the x-axis, But then we also know that f dash x is greater than 0 when it crosses the y-axis. So we know that it's going up at this point, but this is a turning point, so it must drop back down. So we now know that it must go like this. And we know that this is a turning point, so it must turn here and go up here because that's a root. So we've got our root, a repeated root, and we're done there. Okay, identifying a polynomial from its roots, SQA Higher Maths, Specimen Paper 2018, Paper 2, Question 13. The diagram shows the graph of kx, x plus a, x plus b. It shows the points it's passing through, find the values of a, b, k. So you just need to know that the roots tell you these numbers here. So I've got -1, I've got 0, and I've got 2. So let's just highlight that. There's your first root, there's your second root, and there's your third root. So that means I can say that f of x is equal to k times x, double brackets, x and x. First number, x minus 1, so x minus 1, that becomes plus 1 then. And the second number is 2, so it's x minus 2. And now we can go ahead and work out k using our second point here, 1, 2. So when x equals 1, y equals 2. So we get 2 equals k times 1, 1 plus 1, 1 minus 2. So 2 equals k times 1 times 2 times 1 minus 2 is minus 1. So 2 equals 2 times minus 2 is minus 2, minus 2k. So k equals minus 1. A was equal to 1 and b minus 2. Because the form was x add a, so our root told us that -1 is x plus 1, so a is 1. And then x plus b, but b is negative because 2, so it's minus 2. And we're done there. SQA Higher Maths for 18, Paper 1, Question 7 for the equation of a tangent. You've got this curve shown in the diagram. Write down the coordinates of P, the point where the curve crosses the y-axis. So for part A, cuts the y-axis when x equals 0. So subbing 0 in, that's really easy. 0 minus 0 plus 0 plus 5. When x is 0, y is 5, so it's 0, 5. Part B, determine the equation of a tangent to the curve at P. The equation of a tangent, I can find the gradient by differentiation. So dy by dx is equal to 3x squared minus 6x plus 2. And at the point P already we know is x equal to 0, y equals 5. So when x equals 0, dy by dx equals 3 times 0 squared minus 6 times 0 plus 2. 0, 0 plus 2 equals 2. So our gradient equals 2 and our point P, remember, is equal to 0, 5. So y equals mx plus c is the easiest one to use here. Y equals 2x plus 5. Or you could use y minus b equals mx minus a and still get 2x plus 5. Question C, find the coordinates of Q, the point where the tangent meets the curve again. So you're just going to solve simultaneous equations here. X cubed minus 3x squared plus 2x plus 5 was our curve. It's equaling 2x plus 5 at points of intersection. So we can solve that quite easily. If these cancel each other out, if we take it over, minus 2x minus 5, they disappear. So that just leaves me with x cubed minus 3x squared equals 0. Common factor of x squared, so you get x minus 3. So that means that x squared equals 0, so x equals 0, or x minus 3 is 0, so x equals 3. Well, we already know 0 is one of our points, so the second point of intersection is that x equal to 3. So when x equals 3, y equals 2x plus 5. So that is 2 times 3 is 6 plus 5, which is 11. The second point is 3, 11, and we're done there. Completing the square, SQA Higher Maths 2015, Paper 2, Question 2. The functions f of g are defined on suitable domains by these. First of all, it's a composite function question, but then there's a bit of completing the square at the end. So part A, f of g of x Well, f of x is 10 plus x, so that's 10 plus g of x. So that's 10 plus 1 plus x, 3 minus x, plus 2. We need to tidy that up a little bit. So I'll expand the brackets. That's 10 plus 1 times 3 is 3, minus x plus 3x is plus 2x, minus x squared plus 2. So that equals 10 plus 3 is 13, plus 2 is 15. So it's 15 plus 2x minus x squared. Or you can write that minus x squared plus 2x plus 15. But I'll just leave it there. Part B, I've got f of g of x equals minus x squared plus 2x plus 15. So taking minus 1 out of the common factor of the first two terms, I get x squared minus 2x. I've still got plus 15 on the end. So that gives me minus 1 x minus 1 squared, half the middle term, and then take away minus 1 squared. I've still got plus 15. So that gives me minus 1 x minus 1 squared, take away 1, plus 15, which is minus x minus 1 squared. Minus 1 times minus 1 is 1, so 1 plus 15 is 16. And that's it in completed square form. C says another function h of x is 1 over f of g of x. What values of x cannot be in the domain of h? So part C, h of x is 1 over f of g of x, which we've just completed the square of, so it's 1 over minus x minus 1 squared plus 16, or otherwise, but the denominator cannot be 0. So we can just write that for the domain, for that to be valid, the denominator cannot be 0. So that implies minus x minus 1 squared So try to solve that equal to 0 to see what that gives me for it. When it is 0, I can then say x can't be these numbers. So we've already completed the square, so we can just say minus x minus 1 squared equals minus 16. Divided by minus 1 means x minus 1 squared equals 16. Square root on both sides, then you get x minus 1 equals 4 or minus 4. So that means x either equals 4 plus 1 is 5, or x equals minus 4 plus 1 is minus 3. That means x cannot equal 5, or x cannot equal minus 3, and we're done there. That gives us a final answer of 2x minus 2 all squared minus 8 add 11 is plus 3. And we're done there. Completing the square, SQA Higher Maths 2016, paper 1, question 12. Functions f and g are defined on a set of real numbers by f is 2x squared minus 4x plus 5. G of x is 3 minus x. Part A, show, given that h of x is f of g of x, show that h of x equals this. So find f of g of x. So f of g of x is equal to, so f of x is 2x squared, so 2 of g of x squared minus 4 of g of x plus 5. So every time I see an x, I put a g of x in, and then I now substitute my g of x. So 2 times 3 minus x all squared minus 4 times 3 minus x plus 5. So we need to expand our 3 minus x squared. So that's 2 times 3 minus x and 3 minus x. Minus 4 times 3 minus x plus 5. Dealing with all of these brackets, we get 2 times, well, we've got 3 times 3 is 9. minus 3x is minus 6x, and minus times a minus is a plus, so plus x squared. Minus 4 times 3 is minus 12, minus 4 times minus x is plus 4x, and then we've got plus 5 on the end. So that gives me 18, 2 6's is 12x, plus 2x squared, minus 12, plus 4x plus 5. So that equals, we've got 2x squared, and then the x terms, minus 12x plus 4x is minus 8x, and then the number terms, 18 minus 12 is 6, plus 5 is 11. 2x squared minus 8x plus 11, yep, done. Part B, express h of x in the form px plus q squared plus r, so complete the square in other words. So part B, we've got 2x squared minus 8x plus 11. So that's going to equal, well, we take common factor between the first two terms is 2. So that gives me x squared minus 4x. And I've still got the plus 11 hanging on the end. And then we complete the square with the x squared minus 4x. So that's 2x minus 2 all squared, take away minus 2 squared, plus 11. So that equals 2x minus 2 squared. 2 2's is 4, so minus 4, and then plus 11. And then expanding the bracket, we get 2x minus 2 squared. 2 times minus 4 is minus 8, plus 11. That gives us a final answer of 2x minus 2 all squared minus 8 add 11 is plus 3. And we're done there. SQA Higher Maths 2018, Paper 2, Question 4. Express minus 3x squared minus 6x plus 7 and ax plus b squared plus c. So completing the square on this. So we take our function and we take the common factor out, which is minus 3 of the first two terms. So that gives us minus 3. We've got x squared then plus 2x, because minus 3 times 2 is 6x, and then we've still got a plus 7 on the end. So completing the square on this bit, we get minus 3, half the term, so x plus 1 all squared, and take away 1 squared, 1 times 1. And then we've still got plus 7. So that gives me minus 3, x plus 1 squared minus 1 plus 7, and then expanding that bracket, that's minus 3x plus 1 squared. 3 times 1 is 3, is minus times a minus, so it's plus 3 plus 7. And then finally, our final answer, minus 3x plus 1 squared plus 10. And we're done there. Increasing and decreasing functions, SQA Higher Maths 2019, Paper 2, Question 7. Express this in the form px plus q squared plus r. Now let's complete the square. So for part A, if we look at these two, we can take minus 6 out as a common factor. So we get minus 6, and we get x squared minus 4x. 6 times 4 is plus 24. Take away 25, sitting on the end, and then we just complete the square the normal way on this term. So we've got, that gives you minus 6, half the middle term, x minus 2, all squared, and then immediately take away 2 squared, and we've still got minus 25 on the end. Just be aware that this is all times by minus 6 though, so we need big brackets around it. So that gives us minus 6, x minus 2 squared. 2 2's is 4. 4 6's is 24. So we get plus 24 minus 25 sitting on the end. So that's minus 6, x minus 2 squared. 24 minus 25 is minus 1. Part B says, given that f of x is minus 2x cubed plus 12x squared minus 25x plus 9, show that it's strictly decreasing. So to show that something's increase or decrease, we need to evaluate the gradient of the tangent, and always differentiate. So let's look at f dash x. F dash x equals 3 times 2 is 6, so minus 6x squared. 12 times 2 is 24, so plus 24x, and minus 25. So we've differentiated it, but notice that is
minus 6x squared plus 24x minus 25 is exactly what we were asked to do with something with completing the square on part A. So it's to do with the fact that it's completed the square. So we can now just say that f dash x now equals minus 6x minus 2 squared minus 1. If I pick any number for x here in a square, I get a positive number. So that means I can then say x minus 2 squared is positive for all values of x. And that means that when I've got a positive times a negative is a negative. Take away another one, gives me a negative as well. So all I need to then say is, therefore, minus 6x minus 2 squared minus 1 is negative for all values of x. So f of x is strictly decreasing. And we're done there.
(2022) Higher Maths Paper 1, Question 11 was express 2x squared plus 12x plus 23 in the form p, x plus q squared plus r. So in other words, a Higher Maths complete the square question. So there's a couple of ways to do this. Let's go for the most common way. You've got 2x squared plus 12x plus 23. You want a p, so you're going to have to take 2 out as a common factor between the first two terms. So you could write 2 bracket x squared plus 6x, and then you've still got your plus 23 on the end. And that would be a mark for that. Okay, your second mark, completing the square on this, we have to know that we'll then do 2 bracket half the middle term, so x plus 3 squared. And then we need to, that's all in big brackets of course, we need to immediately take away 3 squared. We've still got plus 23. So if you had got this part here, if you'd written x plus 3 squared times 2, you would have got a mark there. We've got 2 x plus 3 squared minus 9 plus 23. So that's 2x plus 3 squared. 2 times 9 is 18, so minus 18 plus 23, which gives us a final answer of 2x plus 3 squared. 23 take away 18 is 5, so plus 5. So if you can get your final mark by following your working through, you get your final answer there. So that's method 1, that's one way to do it. Okay, another optional method that you could use for this, but not often I've seen taught, is to start from this point and expand it and then equate the terms. I'll show you that method now. So if I've got px plus q squared, that's p times x squared plus 2qx plus q squared, and that is now plus r. Following that through a little bit, I get px squared plus 2pqx plus pq squared plus r. If you got that far, you get a mark at this stage for this method, and then equating the terms. So this obviously equals 2x squared plus 12x plus 23. So we should be able to see that the coefficient of x squared here is 2, and the coefficient of x squared here is p, so p is obviously equal to 2. We can see that here, that p immediately equals 2. And similarly, the coefficient of x in the first is 2pq, and that equals 12. But we can immediately work out, since p is 2, that means that 4q equals 12, and q equals 3. And finally, we can see that pq squared r is the constant, plus r, sorry, equals 23. But we already know that p is 2 and q is 3, so substituting that in, we get 2 times 9, which is 18, plus r equals 23. So r equals 5 in this case. If you got pq equals 2, 2pq equals 12, and pq squared r plus r equals 23, if you had written down those equations, you would have got a mark. So we should have written all of them, the top lines, and then working all them out and writing it in completed square form gets you your final mark. So you can't just work them all out. You have to then say what the answer actually is, which is 2x plus 3 squared, because q is 3, plus your 5, because r is 5, for your final mark. And there's your 3 marks in that way. Okay, looking at the discriminant, SQA Higher Maths 2016, Paper 2, Question 2. Find the range of values of p such that this x squared minus 2x plus 3 minus p equals 0 has no real roots. So no real roots, that means for no real roots we can say that that implies that b squared minus 4ac is going to be less than 0. So our a is equal to the number in front of x squared, so that's 1. Our b is the number in front of x, so that's minus 2. And our c is 3 minus p. So subbing that in, we get minus 2 squared minus 4 times 1 times 3 minus p is less than 0. So that's 4 minus 4 times 3 minus p. That's 4 minus 12. Minus times a minus is a plus, so plus 4p. And then that's pretty simple to solve. 4 minus 12 is minus 8, plus 4p is less than 0. So 4p must be less than 8. And therefore p is less than 2. 8 divided by 4 is 2. And we're done there. Okay, the discriminant, SQA Higher Maths 2017, Paper 1, Question 4. Find the value of k for which the equation x squared plus 4x plus k minus 5 has equal roots. So for equal roots, we should know that b squared minus 4ac equals 0. So let's just use that. So our a is 1, the number in front of x squared. Our b is 4, the number in front of x. And our c is what's on the end, k minus 5. So b squared is 4 squared minus 4 times 1 times k minus 5 equals 0. So that's 16 minus 4 times k minus 5. So that's 16 minus 4k plus 20. Minus times a minus is a plus. 16 plus 20, so we get minus 4k plus 36 equals 0. Taking the 4k over, we get 4k is 36, and therefore k equals 9, because 4 times 9 is 36. Okay, the discriminant, SQA Higher Maths 2018, Paper 2, Question 10. The equation m squared plus m minus 3x plus m equals 0 has 2 real and distinct roots. Determine the range of values for m. So 2 real distinct roots. That implies that b squared minus 4ac must be greater than 0. So in this case, our a is the number in front of x squared, which is 1. Our b is the number in front of x, which is m minus 3. And our c is what's left at the end, which is just m. So being careful, subbing this in, we get m minus 3 all squared minus 4 times 1 times m is greater than 0. So we need to then expand our brackets. So that is m squared minus 6m plus 9. And then 4 times 1 is 4 times m. So minus 4m is greater than 0. So that gives me m squared minus 10m plus 9 is greater than 0. So we need to examine the roots. So looking at the roots, we can try and factorize this. We've got double brackets, m and m, 9 and 1, minus 9 minus 1 gives you minus 10. So the roots have m equal to 1 and m equal to 9. And now we need to draw a graph to examine when is the inequality greater than 0. So that's why we look at the roots. So we'll draw a quick graph. We put our roots on at 1 and 9. We know that the shape goes down the way because it's a positive m squared, so we can just draw a quick sketch of a graph. It doesn't have to be anything too fancy. And we're looking at when it's greater than 0, so I'm looking at when it's above the x-axis. So using a different colour pen, it's above the x-axis over here, and it's above the x-axis over here. In other words, when m is less than 1, or when m is greater than 9. And that's our final answer. Okay, the discriminant, SQA Higher Maths 2019, paper 1, question 2. The equation x squared plus k minus 5x plus 1 has equal roots. Determine the possible values of k. Well, if it's got equal roots, that means that we write for equal roots, that implies b squared minus 4ac equals 0. So our a is the number in front of x squared, our b is k minus 5, the number in front of x, and our c is just 1. So for b squared minus 4ac, we get k minus 5 squared minus 4 times 1 for a times 1 for c equals 0. Expanding k minus 5 all squared gives me k squared. Minus 5 times 2 is minus 10, so minus 10k. 5 5s is 25. And then we've got 4 times 1 is 4 equals 0. So that's k squared minus 10k. 25 minus 4 is 21 equals 0. And if we're lucky, that will factorise. So we've got k and k. 7 3s is 21 and 7 and 3 make 10. So it's definitely 7 and 3. Minus 7 minus 3 is minus 10. So k equals 3 or k equals 7. And we're done there. Question 2 says, determine the equation 2x squared minus 8x plus 4 minus p equals 0 has two real and distinct roots. Determine the range of values for p. So two real and distinct roots means that the determinant, in other words b squared minus 4ac, has to be strictly greater than 0. So in this case, a is 2, b is minus 8, and this whole thing here is c, 4 minus p. So we'll just substitute that in. So we've got minus 8 squared minus 4 times 2 times 4 minus p is greater than 0. 64 minus 8 bracket 4 minus p is greater than 0. So 64, 8 4s is 32, 8 times p plus 8p, because minus times a minus, is greater than 0. That gives us 32 plus 8p is greater than 0. Take the 32 to the other side, we get 8p is greater than negative 32. So p must be greater than negative 32 over 8. 8 4s is 32, so p is greater than negative 4. And we're done. Okay, looking at quadratic inequalities. SQA Higher Maths 2015, paper 1, question 8. ABCD is a rectangle with lengths x and x minus 2 as shown. If the area is less than 15, determine the range of values of x. Well, area is length times height. So I'll just write that down, or length times breadth if you prefer. So our length is x, and that's x minus 2. And it says that that area has to be less than 15. So I'll just write x minus 2 is less than 15 to set up my inequality. Expanding my brackets, I get x squared minus 2x is less than 15. I've got a quadratic, so I need to take the 15 to the other side. And we need to then find out the roots and draw a graph to see where it's less than 0. So looking at the roots of this, we've got x squared minus 2x minus 15. If that's factorizable, hopefully, we get x and x, 5 and 3. Minus 5 plus 3 is minus 2, so roots are x equal to minus 3 or x equal to 5. So that means we can draw a quick sketch at the side. minus 3 is over here, and 5 is over here somewhere. It's positive x squared, so our quadratic looks something like that, and it just has to be a quick sketch. Now we're looking to see where it's less than 0. Well, it's less than 0 below the x-axis, so that is in between these two numbers. Minus 3 is less than x is less than 5. But we need to be careful with this question because it is about the area of a rectangle, so we can't have a negative length. X must be, let's have a look. We've got x minus 2 is our smallest, so it has to be bigger than 2. Or the breadth would be negative. And therefore, our actual answer is 2 is less than x is less than 5. Need to be very careful with ones where it's in context.
5 functions f and g are given by f of x is x squared minus 2, g of x is 3x plus 5. We've defined expressions for f of g of x and g of f of x, and then determine the range of values for which f of g of x is less than g of f of x. Let's get straight into it. Part 1. F of g of x equals, so we've got f of x is x squared minus 2, so we've got g of x squared minus 2, and g of x is 3x plus 5. 3x plus 5 all squared, take away 2. 3 3s are 9x squared, 3 5s is 15, times 2 is 30x. 5 5s is 25. Minus 2, so f of g of x equals 9x squared plus 30x plus 23. Part 2, g of f of x. Well, g, I remember, is 3x plus 5, so it's 3f of x plus 5, that's 3 times x squared minus 2 plus 5, so g of f of x is 3x squared minus 6 plus 5, g of f of x 3x squared minus 1. Determine the range of values for which f of g of x is less than g of f of x. So we're saying f of g is less than g of f. So 9x squared plus 30x plus 23 has to be less than 3x squared take away 1. Taking the x squareds across, we've got 6x squared plus 30x plus 23 is less than minus 1. So 6x squared plus 30x plus 24 is less than 0. So we've got a quadratic inequality to solve. So let's look for a common factor. 6x squared plus 5x plus 4 is less than 0. So let's look at the roots of x squared plus 5x plus 4. So that factorises to give us x and x. We've got 4 and 1, plus and plus, so roots at x equal minus 1, x equal minus 4. So we can draw a quick graph to show the roots. Minus 1, minus 4. Less than 0 means below the x-axis. Under here, well, it's under here when it's between these two numbers. So our final answer, minus 4, is less than x, which is less than minus 1.
Maths today, we looked at the whole of polynomials for the Higher Maths 2023 exams. Hopefully you found that useful. Take care, stay safe, and goodbye.